In this video, we're going to talk about arc length and sector area. So first, we're going to start with arc length. So basically, when we have a slice of a circle, sometimes we're interested in knowing what the length of the arc is, not just the degree measurement, but the length of the arc, how long it is. So we're going to talk about how we're going to do that now. So if you take a look at the first question, we are shown the path of a cart traveling on a circular track of radius 2.40 meters. The cart starts at point A and stops at point B, moving in a counterclockwise direction. So the cart's going from here to here. What is the length of minor arc AB over which the cart traveled to the nearest tenth of a meter? So we need to find the length of this arc. So the way that we're going to find arc length is we're going to use the proportion part over whole is equal to part over whole. Now, in this part of the proportion, we're going to talk about arc length. And in this part of the proportion, we're going to talk about the central angles. And keep in mind, part means the slice of the circle that we're looking at. Whole means the whole big circle. So we don't know what the arc length is of the slice of the circle. That's what we need to find. So I'm going to leave that as x. If we go around the whole circle and we measure the length, that's the same thing as saying the circumference of the whole circle. So the circumference of a circle is 2 pi r. And since the radius here is 2.40, let me plug that in. So that would be 2.40 times 2. So that would be 4.8 pi would be the circumference of this whole circle using the radius of the circle. The central angle of the slice of the circle that we're looking at is 165 degrees. And if we take all the central angles of a circle and add them together, they will add to 360 degrees. So from here, we have our proportion. All we need to do is cross multiply. And let's multiply the other way. 4.8 times 165. That's 792 pi. Now using my calculator, I'm just going to divide both sides by 360. So in my calculator, I'm going to use my graphing calculator, and I'm going to get my fraction button, and I'm going to type in 792 divided by 360. And I got 2.2 pi. And the question does say the round, so I do need to multiply by pi in my calculator. And I got approximately 6.9 meters. So the length of arc AB is approximately 6.9 meters. That's different from the angle measurement of the arc. We know that since this is a central angle, the angle measurement of the arc would be equal to 165 to the central angle. But the question didn't ask for that. It asked for the length, the arc length. Moving on to the next example, we're told that we have a circle with a diameter of 24 centimeters. So that means the radius is 12 centimeters because that's half of the diameter. And a central angle of 4 pi over 3 radians. And we need to find the length of the arc. Now, this time, unlike the last one, our angle is in radians. So if we're going to set up our proportion, part over whole equals part over whole, it's going to be sort of the same thing. So first, the arc length over the entire length of the arc of a circle, which is the circumference, 2 pi r. Since the radius is 12, that would be 12 times 2, which is 24. That would be 24 pi for the circumference of the entire circle. Now the central angle is in radians, but it's 4 pi over 3. And we're going to put that over all of the central angles. We're not going to use 360 because that's degrees, but our angles in radians. So 360 degrees, the equivalent to that in radians is 2 pi radians. That's a full circle. And if you forget, you can just convert 360 degrees to radians by multiplying by pi over 180, and that's 2 pi. So a full circle, the equivalent of 360 degrees in radians would be 2 pi. From here, we can cross multiply and we can solve. I know this can get a little bit complicated. So what I'm going to do first is I'm just going to put the numbers into my calculator. So just to make it a little bit simpler for myself. So I'm going to put the fraction button, 4 over 3, and I'm going to divide that by 2. And I got 2 over 3. So I have x over 24 pi is equal to 2 over 3. And I have a pi in the top and a pi in the bottom. Now, when we cross multiply, first of all, if we have a pi in the numerator and in the denominator, that cancels out. So now when we cross multiply, I have 3x is equal to 48 pi. And then if I divide both sides by 3, let me do 48 divided by 3. And I got 16 pi. So the length of this arc is 16 pi centimeters. Now, as you can see, when we're dealing with radians, since the angles in radians often have pi's in them, the solving can get a little bit complicated. So we're going to talk about a formula that we can use instead for when you have radians and you're finding arc length instead of that whole proportion. That proportion is really useful for when you have degrees. So in circle 1, there's a radius of 4, and circle 2 has a radius of 6.5. The arc length of the circle is already given as pi, and the arc length of the circle is given as 13 pi over 8. So the angles here are given in radians. There's no degree symbol, so these are in radians already. Dominic thinks that angle A, those are the arc lengths. But we know that we're finding the angles in radians because if we continue reading, it says Dominic thinks that angles A and B have the same radian measure. So we're finding the angles in radians. State whether Dominic is correct or not. So when you're dealing with radians, we have a formula for arc length. S equals R times theta. And S means the arc length. So for circle 1, I'll label the circle 1, the arc length is pi. R means radius, and here that's 4. And theta is the central angle, which we're trying to solve for. So if we divide both sides by 4, I find that the angle for circle 1 that made this arc length is pi over 4. So that is angle A. And notice how much easier this formula made our lives than having to do that whole proportion with the pi, and it's going to make our life easier here as well. Once again, this formula only works when your angle's in radians or when you want to find your angle in radians. So our arc length over here is 13 pi over 8, and our radius is 6.5, and we're finding the angle. So what we want to do is we just want to divide both sides by 6.5 so we can get theta by itself. Now in my calculator, I'm going to divide those numbers because else this is going to get really complicated. 13 over 8, and then I'm going to hit divide by 6.5. And look what I got. I got 0.25 or 1 over 4 pi. And that's the same thing as pi over 4 since pi is in the numerator. So Dominic is correct. They do both have the same angle measurement. So both of the angles here were the same. So Dominic was correct. Okay. Moving along, we're going to start talking about sector area. So sector area is really similar to arc length. Instead of finding the length of an arc, though, we're going to be finding the area of a slice of a circle, a sector of a circle. So over here in this example, they give us circle O, and we're told that it has a radius of 9. And we're given that the central angle is 120 degrees. And we need to find the area of the shaded sector. So of this circle sector, the circle slice over here. So once again, we're going to use a similar proportion. Part over whole equals to part over whole, just like arc length. Arc length and sector area are really similar to each other. But instead of talking about arc length on the side, since we're talking about areas, we're going to talk about area on the side. And over here, just like the arc length formula, we're going to talk about central angles. So let's start with the part, the area of the part, the sector, the slice. That's what we're finding. It says, what is the area of the shaded sector? Oh, my bad. We're finding the area of the shaded sector. So we're going to need to find the central angle for the shaded sector because that's what we're finding the area of. So if angle AOC is 120 degrees, let me do 360 minus 120. 360 minus 120. And that's 240 degrees. So we're going to need that. Let me put that over here. I was almost finding the area of the incorrect sector. So we don't know what the area of the shaded sector is. That's what we're looking for. So I'm going to label that as X in my proportion. And then on the bottom is going to be the area of the whole circle. And area of a circle is pi r squared. So let's plug in. We're going to plug this 9 in. So we have area is equal to 9 squared, which is 81 pi. So our area of this entire circle is going to be 81 pi. Now, our central angle for the shaded sector, the one that we're finding the area of, is 240 degrees. And we know that all the central angles in any circle always add up to 360 degrees. From here, we can cross multiply and solve our proportion to get the area of the sector. 360x is equal to, let me do on my calculator, 240 times 81. I got 19440, and let's not forget the pi that's attached to it. From here, we just need to divide both sides by 360. Oops. So I have x is equal to, let me divide by 360. I got 54 pi. And the question doesn't say the round, so let's leave it as the exact value. The area of the shaded slice, the shaded sector of the circle here would be 54 pi. Moving on to the next example. We are given that this angle is 30 degrees and that the diameter is 10. I'm just going to fill in that that means the radius is 5. What is the area of the sector formed by the 30-degree angle? So that would be this slice of the circle over here that I'm shading. So let's set up our proportion. We're going to use part over whole equals part over whole. Remember, area is on one side. If it was arc lengths would be on one side, the arc length and the circumference of the whole circle. But since it's a sector area question, we're going to be talking about areas. So we don't know what the area of the sector is. That's what we're trying to find. So I'm going to label that as X. And the area of the whole circle would be pi r squared. And the radius here is 5. So that would be pi 5 squared, which is 25 pi. Then our central angle here is 30 degrees, and we're in degrees. All of our central angles together in a circle are 360 degrees. And if we were talking about radians, just like with arc length, if this was an angle measurement in radians, you would just use the radian equivalent of 360 here, a full circle, which is 2 pi. 2 pi is the radian equivalent of 360. Cross multiplication, 360x is equal to, let's do 25 times 3, 75 pi finally divide by 360. And I have x is equal to, let me do 75 divided by 360 on my calculator. And in simplest form, that is 5 over 24 pi. Or you can write that as 5 pi over 24. Oh, it says to round it. My bad. Let me go back. Let me multiply this by pi. So let me multiply that by pi. I almost rounded incorrectly. The nearest tenth of a square centimeter. So the area is approximately tenth is one decimal place, 0.7 centimeters squared. And I got to fix that on my last one. Area is area, so it is measured in units squared. Let's take a look at one more for this video, and this is a sector area one again. So we have circle O, and the inscribed angle ABC is 36 degrees, and the length of OA, which is a radius, is 4 inches. We need to find the area of the shaded sector, so we're going to need the central angle. Remember, inscribed angles are half the length of their intercepted arcs. It intercepts or opens up to arc AC. So that means arc AC would be 72 degrees. And remember, central angles are equal to their intercepted arcs. So there we have 72 degrees. So now we were able to find the central angle that we need to find the area of the sector. Let's use our proportion. Part over whole equals to part over whole. We're looking for the area of the sector, so that's going to be x. And let's put that over the area of the entire circle, which would be pi r squared. The radius is 4. 4 squared is 16, so that would be 16 pi. And then we're going to put the central angle, that's why we needed it, over 360, which is the total of all the central angles of a circle. So here we have 360x is equal to, let's do 16 times 72. And I got 1152 pi. And finally, we're going to divide everything by 360. And it does say to round to the nearest tenth. So I'm going to remember that this time. Let me put that all into my calculator. And I got x is approximately 10.1 inches squared. The area of the shaded sector is approximately 10.1 inches squared. Before we get off of this video, let's do one more arc length question just for fun. So let's take a look at this one over here. A central angle whose measure is 2 pi over 3 radians. So that's important. We're in radians. Intercepts an arc with a length of 4 pi feet. So we're talking about arc length here. And they give us the length of the arc. Find the radius. Since we are in radians already, I'm just going to go to my arc length formula. S equals to r times theta. The arc length is 4 pi. We need to find the radius. And our angle is 2 pi over 3. So to get r by itself, we just need to divide both sides by 2 over 3 pi. Now there is a pi in the numerator and the denominator, so the pi's cancel out. And I'm going to go to my calculator to divide the coefficients. So on my calculator, I'm going to do 4 divided by, let me get my fraction button, 2 over 3. And I got 6. So the length of this, the radius that makes this arc length is 6. And that would be 6 feet, because the question does say feet. And taking a look at this one over here, a dog has a 20-foot leash attached to the corner where a garage and a fence meet. So here's the leash attached to the corner, and that is a 20-foot leash. So that would be the radius here. When the dog pulls the leash tight and walks from the fence to the garage, the arc the leash makes is 55.8 feet. So that says it's from the fence to the garage. The arc length is 55.8 feet. So they're giving us the arc length here. And we need to find the measurement of the angle between the garage and the fence in radians. Even though it's in radians and we can use our formula, I just want to set up the proportion because we've been using the formula a lot for the arc length questions with radians. But when you have degrees, the proportion is, sometimes more useful. So because the formula can only be used with radians, so I do want to check it out with the proportion as well. So arc length go on the side. So the arc length of this part of the circle is 55.8. And then the total circumference goes on the bottom. And the radius is 20. 20 times 2 is 40. So the circumference would be 40 pi of the entire circle that's not drawn here. And on the side, central angle, that's what we're trying to find. And we're in radians, or we want to be in radians. So I'm going to use 2 pi, which is the equivalent of 360 in radians. I'm going to cross multiply 55.8 times 2. That's 111.6, and I'm not going to forget my pi. Multiplying the other way, that is 40 pi times theta. Just going to divide both sides by 40 pi to get theta by itself. These cancel out. Let me divide by 40. And I got that the angle is 2.79 radians. And if I wanted to just double check, I can double check really quickly using the formula. S equals to R times theta to double check myself. 55.8 equals to 20 theta. And if I divide both sides by 20, let me do that on my calculator, 55.8 divided by 20, I got the same thing. I got that theta is equal to 2.79, so I can check my work.